Okay, ladies and gentlemen, good afternoon. Excuse me, ladies, do you mind to start? Thank you. Okay, so last time we started chapter 10. Right, before we do anything, let me check the calendar here. The calendar seems to me doesn't want to work. Oh, it's working. So 1, 2, 3, 4, 5. So next, depends how we finish today. Next week we will practice, right? So if you require and have still questions with simple interest, and if you require help with simple interest, please have those questions ready, okay? So I will prepare on my side something. You guys have your questions, so we will have these two classes in form of like Q&A or whatever I prepared. Okay, whatever comes first. Okay, so and then we will have a review on Tuesday and first test on Thursday. Okay, that's week number 6. So that's October already. Okay. 1, 2, 3, 4, 5, 6. October 10 will be first test. Okay, so let's recall. I'm not gonna recall what logarithm is, just formulas. So n is what? Yeah, right. Let me put it more convenient position. So n is logarithm future value from over present value, logarithm 1 plus I. And this formula pairs with the formula for t, this one. Okay, we good? So we did a few questions, right? I think we did this one. Did we do that one? No. Okay, try. So let me put this formula for you. Okay, take a moment and do it. So first thing first, we need to identify what we know, right? And then realize what they want us to do. So what we know. So we have two amounts. One is growing to another. So most likely 5,000, it's a present value, right? And future value will be 15,000. And I have monthly compounded interest rate at 6%. Okay. So when I need to find n, formula is here. So what is it? Future value I have, present value I have, I. if I calculate I will find this much. And then what? Logarithm. So let me put in this form. So what you see, guys, remember from last time, what we calculated? We calculated doubling of money, right? Now what's happening with money? They grow how many times? They triple, right? So what's happening with my logarithm? Logarithm 3. So when we doubling, it was logarithm 2, right? So what's going to happen if my money grow 5 times? Logarithm 5, right? Okay, anyways, it's just the observation. So let's calculate. So I have 220.271.3073. So that's what units are there? So what is it? Liters, bags of potatoes, kilometers, what is it? In months, yes. It's month. So next step, what? To find T. So basically I divide by 12. So that's years. Well, for this question, we could say 18.4 years. But what I want us to do now, I want to practice and see how many months I have. Right? Let's see how to calculate that. So we work with that number. I know for sure that I have 18 years, right? So this tail, what is left out of that n, we just t, what we just calculated, that should be months, yes? So if I do 12 times this, so what I have, oh, something's weird. Okay, one more time, because I have gremlins in my calculator. Okay, now, minus 18 times 12. So I have 4. So what I have, 18 years, 4.27130726264. What is it? It's month already, right? Yes or no? Now, can I calculate number of days? Yeah, this tail will give me what? Days. Well, I will take 30, right? So if I take this tail times 30, of course it's going to be approximate, right? So I will have 18 years, 4 months, and about 8 days. So a question asking you find number of years in months, you already know how to do it. Good?
We need to show month and day also.
No, days, no, I'm just for the practice. Well, it's 8.139. So what next step is hours, then seconds, minutes, seconds. No, we're not going to play with that, right? But the idea is there. It's the same idea, right? Yes. Had a question? Oh, you just stretched. So that's how we convert this decimal number for years to years and months. Okay, good. Yeah, let's move forward then. Equated date. So what is equated date? Remember, we were calculating amount of last payment. We had two agreements, one agreement and a replacement agreement. And the question was actually find the final payment. Yes? Remember that. So what we knew all the dates when we made a payment, right? What we didn't know amount of money we're supposed to pay, right? Remember? Now we know all amounts we're supposed to pay. We don't know when that last amount has to be paid. And the question is to find when. So this day when this amount paid, called equated date. Understand? Guys. So let's see. Yes, for the equated date, make a note. Equated date questions require focal date, require to use a focal date, and this focal date always now. So we need focal date, and that date is always now. So you need a pen or you have a spare pen? Oh, he doesn't here, that's fine. Okay, you need a pen or you okay?
Yeah, you know.
Yes. Here. You can have it. It's somebody donated in class anyway, so
Thanks.
keep it. Okay, so let's make a picture. So what I have, a loan 2,000 taken out today, so now $2,000 is to be repaid by payment of 1,200 in 6 months. So let me take, for example, orange, 6 months, $12,000, and a final payment of $1,000. If interest J12, 12%, it means what? I is 001, right? When should the final payment be made? Provide you answer in number of days. So sometimes here I suspect $1,000. Now question, did we pay interest here on this loan? How much? Yeah, okay. How much requires answer in dollar amount? No. How much did we borrow? How much did we pay back? 2,200. So what is the interest? 200. We good? Okay. Now the question is when this $1,000 has to happen. Now, many times I have this question, how do I know where to put this question mark? So remember, as soon as this question mark in the future, we okay. Understand? So no matter where you put it, if you have multiple payments, doesn't matter what position you put that unknown date, as soon as this date in the future. After you calculate the actual day, you will know exact position of that question mark. But this picture And it's just the help for us to visualize the question, nothing else. It doesn't have to be 100% accurate. Understand? Okay, so as I said, the focal date is here, right? So I have again two agreements. I have 2,000, that's a loan, and I have two payments. So 2,000 is already in the focal date equals 2. Now 1,200 I have to bring back, 1,000 I have to bring back, right? So 1,200, 1.01, now 6 months, exponent minus 6. Yes? No? Yes. Plus $1,000, 1.01 exponent, I don't know, so I leave it minus n. And now people, interesting game starts. Okay, let me see. Okay, I don't have extra page, so we'll squeeze it here. Now interesting game starts. So let's calculate everything what we can. So I have 2,000 equals 2, 1,130, 45 plus 1,000, 101, negative n. Now transfer that to other side. Course, algebra, change sign, yada yada. We all remember that, right? Now, what's going to happen now? Now I need to divide both sides by 1,000. And create logarithmic equation. So logarithm equals to logarithm now what I have, remember that feature of the logarithm, logarithm a to exponent n is n logarithm a. So this minus a jumps out from the logarithm. Logarithms I will calculate later. And then n equals 2 logarithms 0.86955 divided on negative logarithm 101. So now we can calculate that. Don't lose that minus because what? The top, the numerator is negative. So 14,04771,807. And that would be what month, right? Then we take this value divided by 12. And times 365. So we converted 2 years first and then 2 days because we need number of days, remember? So T is approximately, let's do it 427 days. So that's when we use algebra, that's how we solve that equation. Is that great? Okay. So let me know when you're done. I'll show you something interesting. Are you done? Now let's have a look at that equation. Now we will play the game of logic. So have a look on that equation. Does it look familiar? Maybe you recall any formula here. Present value, yes. So that is yes or no? That's why I can say that present value is 869.55. Future value is $1,000. Just make sure that this equation has future value more than present value. Otherwise, you will calculate date in the past. And instead of doing all this black magic I call algebra, we can use that formula right away and say n is logarithm future value over present value, logarithm 1 plus I. And therefore I have logarithm 1,000 divided on 869.55, logarithm 1.01. When you calculate that, you will have exactly the same number. So how did you like that method? Better? So let's use it. Most of the questions, they have multiple ways to solve it. You just need to find it. Yeah, result is the same. Any questions, ladies and gentlemen? Well, let's move forward then. Yeah.
Looks like in the right logarithm equation, isn't the bottom number supposed to be negative or no?
Top number negative, but minus supposed to be here because minus n.
No.
No. Now, this is positive value and this is positive value. No negative values here anymore. What's your formula? That's your formula, right? So you divide 1,000 on 800, not vice versa. And you will have, right? So when we went through the logarithmic equation, what happened? We divided value what is less on value what is greater, and we received what result less than 1. And logarithm, if you look at graph, logarithm whatever value less is 1 is negative. Okay? But it's already calculus, so we don't do calculus here. Okay, so let's move forward. An existing financial agreement requires 3 payments. So did I answer your question?
Yeah.
Oh, okay. It requires 3 payments, 2006, 30,015, 5,024. Alternatively, a single payment equal to the sum of the required payment could be made. If money is worth 9% compounded monthly, when should the single payment have to be made? So when question asking this, when should be single payment or when the payment should be made, it means you deal with equated date question. It means you need to calculate n first, then find t, and focal date is now. Okay, so let's start together for split second, and then I give you time to do it on your own. How much we supposed to pay here? $10,000. Does everyone understand that? Yes, no? If no, let me know, I'll explain. Alternatively, single payment equal to the sum of the required payments. So 2 plus 3 plus 5 gives me 10. So we need to pay lump sum of $10,000. Question, when? Okay, do it. So I start with picture. You guys compare your picture and my picture. Something like that. Your question mark might be in different position, but it doesn't matter. As soon as this in the future, we okay. Now I have two agreements, right? The blue one and the orange one. So orange agreement has one amount, so I can create the equation right away, right? So 2,000, 9% monthly gives me 0.075. And now minus 6 plus 3,000 minus 15 plus 5,000 minus 24. Agree? It has to be equal to $10,000. And here I have minus n. Minus n. Oh. Let's calculate everything what we can. Guys, little hint, when you calculate present values, your results should be less than original. Right? If for any reason you found the greater one, you made a booba. Okay, so. So now quick analysis.
How can you do that formula?
Yep. Now I say this value is present value, this value is future value. I make sure that present value is less than future value, and it is, right? And formula says n equals 2 logarithm future value over present value, logarithm 1 plus I. And I have logarithm 1,000, actually 10,000 over 8,733.40 divided on logarithm 1.0075. So let's calculate. If you need help with calculation, again, I will show you. So what is that? What units? Months. It's not monthly, those are months. We compound monthly, therefore those are months. Now, when my diagram, my old data operating with month, so I can have answer approximately 17.5 months, right? That's it.
If I mistakenly taken the 10,000 in between 2 and 3,000.
Oh, if you put here,
Yes.
it doesn't matter because it's still in the future and you did present value formula. No, it's not a mistake. It's not a mistake. That's what I told you before. No matter where you put your question mark, here, 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 or over there, as soon as it's in the future, you will receive correct equation. Of course not. Why? Your focal date is in the past. So you have to bring everything to the past. No future value formula, no.
If I take focal date anywhere else.
Well, no. Here, focal date always now.
How can I understand focal date will be?
Well, if you deal with, well, few hints. You need to find date. So you have two agreements, one agreement replacing another agreement, all values known. What is unknown is date of payment. So right away, connect this situation to equated date question and focal date now. So it's like sun is shining, water is wet, girls are beautiful, right? So that's kind of this situation. Yes. What you don't, what part? You didn't get that? Well, let me show you algorithm again. So try it. You take 10,000 divided on 8,733.40. Yeah, 873340. Well, how else it should be if I have this value here? So then you press ln. One, two, three values. I add them up. 773. Okay, let's calculate again. Well, I have 877340. Recalculate. What do you mean same answer?
773.
No. If you add this 3, you have this number. What are you talking about? If it was 7,000 here, you would find a different number of months. It's 833. Here, you mean? Okay, so let's make it more clear. Is it better? Oh, typo. 773, of course. Well, no, because I used the number is the same. Number is the same. What I do, I use calculator smart. The last thing I calculated is this number. So what I did, I pressed 1 over x times $10,000. It's the same thing if I 10,000 divide on that, right? So logarithm, then I go divided 10075 logarithm equals. So that sequence should give you that answer. Yeah, now better? Okay. Any other questions? Okay, so when George borrowed money, he originally agreed to repay loan by making 3 equal payments of 1,500, with the payment due now, another payment due 2 years from now, and the final payment due 4 years from now. Instead of the original payments, he plans to pay off the loan by making a single payment of $5,010 if interest is 10% compounded annually. When will he make the single payment? Okay, guys, it's all yours for next 2-3 minutes. Do it. Okay, let's see. What we do. Let's make a timeline. So now 1,500. So we don't know when he took this loan, right? And we don't care. We know that today he has to pay 1,500, but probably he didn't have money. So 2 years from now, 1,500. And 4 years from now, 1,500. So instead of that, somewhere here, maybe, we don't know for sure, he will pay $5,010. So J1 is 10%. It means I is 1, 0, 1, right? Focal date is now. So what we do? We take 1,500. The first payment, it's already in the focal date, so I use it as is, plus 1,500, 1.1 negative 2, plus 1,500, 1.1 negative 4. Good? You have the same? Equals 2, 50, 10, 1.1 negative n. So n. Let's calculate. So 1,500 plus 1239.67 plus 1024.20, 52 equals 50, 10, 1.1 negative n. Three 764.19 equals 50, 10, 1.1 negative. Now that's the moment when magic starts, right? And we say that is present value, that is future value. And all I have to do is calculate my formula. And so 2.999713326. What is that?
Yeah.
Years. So it is no point to convert that to years, right? It's going to be the same. So about what? So I put mark right. So the question, did I put mark right? Yes or no? But so 3 years from today, when he pays, was it a good decision for him, money-wise? Did he pay more or no? Well, instead of paying 3 times 1,500, he decided to pay this $5,000. So was it a good decision? You say yes. Why? Okay, tell me why. So he paid. You think so?
No.
1,500 times 3, how much? 4,500, right? And he pays over $5,000. So he pays more. Okay, but well, you never know. what might be the situation.
So why he decided to pay?
Probably he didn't have money at the moment. Right? Probably he didn't have money at the moment. So just a little since we did talking about options. So for example, TD on line of credit charges for minimum payment, charges percent, only percent, accrued percent. Okay, so when you have line of credit, your minimum payment will be percent accrued on the amount you borrow. CIBC, for example, charges percent plus 3% from outstanding balance. Now let's analyze these two products. Both are great. If you don't have money, probably TD will serve you better because you pay less than you pay with CIBC. You don't pay that 3%. On the other hand, CIBC forces you eventually repay the loan because this 3% will reduce your principal, right? When you pay interest only, you will never ever pay this loan back. You understand that moment? Yes or no? But if you discipline and if you have extra cash, you always can pay extra. You're not obliged to pay exact minimum payment. You can pay more. That's demand loan, remember? So you pay as much as you want. Oh, in this case, it has to be what? Minimum payment. Otherwise, they're gonna hate you, and you don't want that when banks start not liking you. Okay? So that's just a little step to the side. So where we are? I believe here. Right? So 3 years. Any questions so far? So on this happy question, we finished N calculation. What time is that? Let's have a break. I think we deserve that. So be back at 1300. That's 10 minutes. So back at 1300. Okay, so any questions about that end game? I think we should be all right, right? Okay, the next step for us is to learn how to calculate I, which is interest rate. So again, we start from the main formula. Oops, present value. This time we don't have exponents here, but I mean, I is not in the exponent, right? So what we do, we divide both by present value. And we find the root. And finally, that's your new formula. One over n is exponent. Well, did I show you how to calculate n with the calculator? Yes or no? No? Okay, so let's come back then. Let's do here. So what we have? We have present, oops. We have present value 2000. We have future value 244038. We have J4, 4%. So calculator. Algorithm very similar to what you already know for future and present value calculation. So you second clear TVM, then you set PY as 4, so you let calculator know how often you compound, right? Everybody remember how to set PY? Yes, no? Second PY, 4, enter, second quit. That's how you do it. Now, N we're looking for N. So next button is IY, so 4 for IY. Then present value we have 2000, change sign, PV. Then 244038, that's for future value, and compute N. So idea is exactly the same. You program calculator with what you have, and you calculate what you're looking for. So let's do it. Okay, PY is 4 IY, 2000. Negative present value, 244038 future value, compute N. And I found here N equals to 19.999, whatever, 99. How many nines? 5, 6, 7, 1. So that are quarters, right? Yes or no? So when I divide by 4, that's 4.99999 years or 5 years. Okay. So idea is exactly the same what we did before. Clear memory, set number of compounding periods, then set all buttons you know, compute button you don't know. That's it. Good? Guys, any questions? Okay, that's how we do. No, that's not that. It's here. So, yeah, I will show you calculator right away, so I don't forget. On this exercise, we do both formula and calculator. So what is the annual compounded rate if 200 accumulates to 318.77 in 8 years? Yes, one more thing. This formula, same as formula for n, has a pair. Pair says J has to be calculated as I times n. So formula gives you periodic interest rate. You need to find nominal interest rate, which is J. And because I was J over M, right? Remember? From here, J is I times M. That's what it is. Good? So these two guys, they come together. Okay, what is the annually compounded rate if 200 accumulates to 318.77 in 8 years? So what I have present value 200. I have future value 318.77. I have time 8 years, and I need to find J1. J1. I don't have direct calculation for J, but I have calculations for I, formula for I. So 1 over n minus 1. So let's analyze what I have, what I don't have. Future and present value I don't have n, right? So n is Tm is 8 times 1 is 8. So my formula will turn to this. 318.77 over 200 exponent 1 over n minus 1. Now algorithm, how I calculate that? I take 318.77 divided on 200. Then I go equal. Do I need to press equal? Let me check. No, I don't have to actually. It doesn't matter. So y2 exponent x. Now I put n, which is here supposed to be 8. Why I put n? 1 over 8. And guys, friendly recommendation, do not calculate that value, 1 over 8. Don't rush. You will calculate it right here. So 8, then you press 1 over x. This is your 1 over 8. Equals minus 1 equals. Actually, you don't have that equals as well. So just minus 1 equals. Good, let me make this 8 more beautiful. So you find fraction, then you calculate exponent. You don't have chance to enter value 1 over 8. So you enter 8 and then you make it 1 over 8 by pressing button 1 over x. Understand? That's it. So what is the answer? I equals to 0.06. Now 4 zeros, 16. So times 1, because we need to what? Find J1, right? Times 1 is 0.06. So what I do, I just drop to those zeros. That is the answer. That is the answer.
Also, it's the same in, when we do the calculations, instead of using 1/8, we use the decimal form, right?
You can, but why would you do that? Let's calculate 1/8. Well, 1/8 is easy number. But if you, for example, have 1/3, it's 3 to what? To infinity, or you have some other number, it will be. So I recommend, you can, don't take me wrong. If you like, go for it. I gave you the easiest, most efficient way to calculate it. Your choice. You take my way or not. As soon as, give me the break. As soon as results are the same, use your own way of calculation. Okay? Now, how we use calculator. So second, same story, clear TVM. Then we set PY. This time is 1. Then I go 8 for N. IY, I don't know. 200, change sign for present value. 318.77 for future value. And then I compute IY. Let's do it. And I have 6.000016,007, right? And little star here, meaning that this number continues for longer than that. So approximately 6, right? We good? Okay, so let's practice. Yeah, sure. Make sure you know you did it.
And you're pretty very well.
Say it again. Or if you have months, remember time always in years. You use formula, it means time in years. You have months, convert it to years. You have days, convert it to years. Whatever format you have, except years, you convert to years, always. Same with percent. You have percent value, convert to real value. You cannot use percents in the formula. We okay? Okay, so let's do this one. Calculate nominal annual rate of interest compounded monthly if 1200 accumulates to 1862 in 5 years. Okay, here's your formula. Do it. So what we have? Monthly compounded, right? So I have present value 1200. I have future value 16, 18, 62. I have 5 years term. So I know I need N, so 5 times 12, and I'm looking for J12, right? 5 times 12, it was 60 this morning. So I go the 16, 18, 62 divided on 1200. Here is 1 over 60. Now, if you want to calculate that separate, right? Yes or yes?
You
Right. So that's why I offer you to follow my way and you will have less trouble. -1. So I is what? And I have 0, 0, 0, 4 and bunch of nines, right? 1, 2, 3, 4, 5, 8. Typically I say no round, but here is obvious. Yes? Times 12, what is it? 6%, right? So J12 is 6%. Calculator? Yes, no? Okay. So second, clear. EVM. Guys, you don't have to do both on test. You choose one way of calculation. Either you use calculator, then when you use calculator, I want to see this formula, this process as your solution. Okay? So that will be your answer on a test. If you decided to use a calculator. Set PY is 12, right? So N, 60 for N. Then IY we're looking for 1200. Change sign for PV. Then 16, 18, 62. That's future value, compute IY. So let's do it. It happens to be 5,999,997,727, so 6%. Good? Any questions? Quite often people say, I forget to find J. So don't. If you keep, huh?
1 over 60.
What?
Over 60 month. If I give 1 over 5.
Where you got 1 over 5? Yeah, but you use N, not T. Formula says 1 over N, not 1 over T. And N is what? 5 years times number of compounding periods, which is 12, and the result you have 60. If you do 1 over 5, you will find what? Some 5 compounding periods. I don't know what is that. Okay. So let me see something, what we have. Yeah, let's do this too, and we'll leave that for the next time, because this is, or maybe we start, we'll see. We'll see how it will go. So at what nominal rate of interest compounded quarterly will money double in 10 years? So try it, not try it, just do it. So all this philosophy about doubling money, remember, present value, future value. Again, if it's difficult, pick any amount for your present value. And times 2 will be your future value, right? So what I have that my future value is 2 times present value. Correct? So future value 2 times present value. Compounded quarterly interest rate, money double, 10 years. T is 10 years. Okay. J4, that's what I'm looking for. So let's start with the formula first. I need N. So N is 10 times 4. It's 40. So I is 2 PV over PV 1 over 40 minus 1. So I is 2, 1 over 40. Yeah, I don't need that bracket here. Minus 1. Let's calculate. So I have 0, 0, 1, 7, 4, 7, 9, 6, 9, 2. And now I remember that I'm looking for quarterly compound interest rate. So I need 2 times 4. Yeah, 0.069918. Oops, 18768. So I would say better to keep 6.99%. Then you round to 7. Here it's not so critical, guys. We learn principles, how money works, right? We're not calculating real amounts. If you operate within $1,000, it doesn't matter. But if you operate trillions, then it's big deal. Then you keep everything, all these numbers you will be using, right? All depends. Okay, let's do what calculator. So second, clear TVM, set PY as 4. So N is 40 for N. Now what I would do for present value? Yes, 1 or any other amount. 1, then 2 for future value, compute Y. So let's do it. And I found 6.99%. So we can keep 6.99. So to make it to what explain the reason why we didn't round, that's probably we can do that. 699.19. But if you round, that's fine as well. Okay, suppose, or this one interesting, and we will talk about it after we're done. So suppose $1,000 earns interest 93.81 in 1 year. What is the nominal annual rate compounded annually and monthly? So let's do it together. Or you want to do it? Okay, do it. 2 minutes. Okay, so what we have? This time we know present value is $1,000 and we have amount of interest 93.81. So what is possible? Possible is to calculate future value. Yes or no? Yes. So let's do one. I is what? 1093.81. Yeah, and we know time T is 1 year, right? 81 over 1,000. Now, what I compound annually, so exponent 1 over 1, I put specifically that fraction, so just to stress that I compound annually, okay? So what is that? So I have 0.9381. So J1 is 9.381%. Let's do the second one. I is same numbers. The only I have 1 over 12 here. Everybody know why 1 over 12? Monthly compounded for 1 year, right? So 1093.81 divided by 1,000. 1093.81 divided by 1,000. I have 0.00750023.8. So times 12, right? I would say we can drop that. And I have from here J12, 9%. So let's analyze that game. So what I have same starting condition, meaning I have same amount to invest for same time interval. In this case, $1,000 for 1 year. Yes? What I have different, I have two different interest rates. One interest rate is compounded yearly. Another interest rate is compounded monthly. But what happened in the end of the game? I have the same outcome. I have the same interest amount. Do you see that? Yes or no? What kind of?
Annually, you pay a little bit more.
What you pay? 93.81 you pay.
You get it. 9.38.
Guys, we have 93.81 as interest for 1 year. Yes? We used that. Okay, let's check it. Okay, if it is the issue of this gazillion particle of the sand. So let's see here. Future value is $1 times 0, 0. No, not 0. Oh, not $1, 1,000. Why $1? $1,000. 1.09381, right? Exponent 1. What is that? 109381. Yes? Let's do here. Future value is 1,000. 1.0075 exponent 12. Let's calculate that. $1093, 806, 898. Well, little different discrepancy because of those values. That's again, you see how accuracy is important, right? But for this amount of money,
So when we are making a deal, it's better to have the rate of interest monthly or
well, depends. You know, it is a joke. Johnny, how much is 2 times 2? Johnny asking, are we buying or we selling? So answer for your question, are we buying or we selling? Are we taking money as a borrower or we lending money? Right? And how much?
Yeah.
And the amount. Okay? That's why I say calculate before you do any move. Then you will have answer for your question, you know? But for the purpose of what I want to explain you now, we consider these two amounts the same. So what situation we have? We have same present value, we have same term, we have two different interest rates, but the same result. In this case, those interest rates we call equivalent. So if two interest rates for the same amount and the same term produce same result, those rates are equivalent. Okay, that's what I want you to say. Equivalent interest rates. Now the question is, what is the effective rate? For the effective rate, write this down. Effective rate always compounded annually. effective rate always compounded annually. It means that any annually compounded interest rate could be treated as effective rate of interest or some interest rate, right? This interest rate we don't know yet. It's possible to calculate. But as soon as you see rate compounded annually, it could be treated for some other rate as effective rate. Why we need those effective rates? We will use that to compare investments to see which one is better. Okay. Now look at that here. What I have. Effective rate. And because these two are equivalent, I say that, you see, this one is equivalent to that one. But one of them compounded annually, so I treat it as effective. And I say that 9.381% is effective interest rate for 9% compounded monthly. Because they do the same job. Okay? Understand? That's what effective and equivalent rates are. That's how they relate it. Now, there is a formula for effective interest rate. That's the formula. How you calculate effective interest rate? Of course, you need a starting point of any other rate compounded different from annually. Because if you have annually compounded interest rate, it's effective to itself. It's already compounded annually, right? But if you need to find effective interest rate to any other rate compounded different than annually, then you use this formula and calculate it. Emma. It's F. They use letter F. F, 1 plus I. So M, you know what M is. I, you know what. And this is effective rate if we use base JM. So this, the rate, and that is effective rate for that rate. Okay? So let's see. What time is that? Well, let's calculate at least something. Assume you're given a choice of term deposit paying 7.2 compounded monthly or an investment certificate 7.25 compounded semi-annually. Which rate offers the higher rate of return? So you have two options. One option, you invest any imaginary amount or amount you have and calculate future value for each of them, right? And see what is better. The other option, let's say what we have. We have J12, 7.2%. For this, I calculate effective rate of interest. What is M? M is 12. What is I? Let's calculate. So I have 1006 exponent 12 minus 1. And here, guys, we don't round at all. We keep all the tail because sometimes the difference is so small. So if we round, we don't see. So that's effective rate of interest for J12, 7.2%. Because right there, from the glance, you cannot say which one is better. The difference is what? 5,000ths of the 500ths of the percent, right? But they compound different amount of time. So which one is better? We don't know. So let's see what happens for J2, 7.25%. So F is 1 plus I exponent m minus 1. So I, in this case, 0.0725 over 2. 1.03625. And of course, we don't round I here either. That's 0. That's not 1. 0. So 1.03625 exponent 2 minus 1. 0.07381 or 0.63. So now I compare these two rates. Which one is better? The black one or blue one? Huh? Black one is better, right? Why? Because number is greater. Now, guys, we have same amount of money. We invest using this percent compounded annually, and we invest this percent compounded annually. It's obvious that the first will give me more money as a return. Yes? Make sense? That's it. That's the game. That's how we use effective rate. Well, you want me to develop the formula, or you can just take it and use it? Well, I can develop formula if you like. And we will use that development later for a calculation I'll show you. So let's say you have J1 and you have some amount, whatever, J1. And you have JM, I2. So let's invest $1 for 1 year. What you have? 1 plus I1 exponent 1. Yes? That's the future value for $1 for 1 year. And because those rates should be equivalent, they should be equal, right?
But we don't use the -1 here.
Where is -1?
It's,
The future value formula has no -1.
oh,
I operate 1 year, so n is m. Here I know for sure I compound once a year. Here I put m because I can use any. Now what is it? 1 plus I equals 1 plus I2. I1 is 1 plus I2, m minus 1. So same formula, just different letters a little bit, right? Okay, this procedure we will use later on to calculate if we have two different rates and we want to find if equivalence rate. Okay, ladies and gentlemen, on this happy note, see you next week. So we will continue game for chapter 10, and the rest of the time we will review material for 9 and 10. Remember, if you still have questions about simple interest, you're welcome to bring in us, okay?